In this video, we are going to learn how to solve problems involving motion in a circle for physics. So we are going to practice with 7 repeated questions for this video or for this topic. Let's get started. The first question here says the force that tends to pull an object undergoing circular motion towards the center is what? So the correct option on this question is option D, centripetal force. It's not centrifugal force, it's not tension, it's not reaction. Now note that centripetal force is the opposite of centrifugal force. Alright, centripetal force is the force that pulls an object undergoing circular motion towards the center, whereas centrifugal, this option B, is the one that pulls an object undergoing circular motion away from the center. Alright, so centrifugal is the opposite of centripetal. For this particular question, since the force is pulling the object towards the center, is centripetal, which is what option D. The next repeated question is this question. It says the law that explains the path of motion of the earth about the sun in an elliptical manner was stated by. So the correct option in this question is what option B, Kepler. Take note of this particular question. I've often seen it repeated. The same thing is applicable to the first one we just finished answering. So let's go to the next repeated question, which will be this question. It says a particle in a circular motion performs 30 oscillations in 6 seconds. Its angular velocity is what? Alright, so for this particular question, let's write down the parameters. Okay, so for this particular question, we have the time to be 6 seconds, and we also have a particle in a circular motion perform 30 oscillations. So we have number of oscillations to be 30, number of oscillations. Now note that these parameters we have here will give us the frequency of this circular motion. So frequency is number of oscillation per unit time, so that's 30 over 6, which will give us what? 5 Hz. Okay, so this for frequency of this circular motion. Now that we have frequency of this circular motion, the formula or another formula for finding frequency of a circular motion, we have it to be frequency equals W over 2 pi. Alright, so in this expression, this W here is our angular velocity. So when you plug in the value to make W the solid formula, we're going to have frequency is now 5, right? So it's now 5 equals W over 2 pi. When you cross multiply, your W will be now 5 times 2 give you 10 pi, okay, radian per second. So the correct option in this question is option B. Alright, so take note of this particular question as well. That's it. Let's wipe this and solve the next repeated question. Okay, so the next repeated question will be this one. It says, which of the following is true of a particle moving in a horizontal circle with constant angular velocity? Both energy and linear momentum are constant. The linear momentum is constant, but the energy varies. Option C, the energy is constant but the linear momentum varies. Option D, the speed and the linear velocity are both constants. Alright, so guys, for this particular question, the correct option is option C, which is the energy is constant but the linear momentum varies. So take note of this particular question as well. I've often seen it repeated. Alright, so let's go over to the next repeated question. Now before we attempt this question, if you are new to our channel, ensure that you are subscribed to our channel guys by hitting the subscribe button. We really appreciate this. So having done that, let's answer this question. It says a piece of stone attached to one end of a string is whirled around in a horizontal circle and the string suddenly cuts. The stone will fly off in a direction A, parallel to the circular path, B, toward the center of the circle, C, tangential to the circular path, D, perpendicular to the circular path. So the correct option this question is option C. The stone will fly off in a direction tangential to a circular path. Alright, so let's go over to the next repeated question, which is this. It says a gramophone record takes 5 seconds to reach its constant angular velocity of 4 pi radian per second from rest. Find its angular acceleration. So for this particular problem, all you need, so we have the angular velocity doubly to be 4 pi radian per second, and we have the period, that's time, to be 5 seconds. So we are looking for the angular acceleration. Angular acceleration basically will be, let me use A to represent it, will be angular velocity over time, which will give you 4 divided by 5. So let's punch it in the calculator. It's going to give us 0.8. But let's verify. 4 divided 5, we have it to be 0.8. So the correct option in this question is option C, which is 0.8 pi radian per second square. Okay, so lastly, let's wipe this and solve the last repeated question. Alright, so the last repeated question will be this question. It says an object of mass 2 kg moves with a velocity of 10 meters per second around the circle of radius 4 meters. Calculate the centripetal force on the object. Alright, now guys, centripetal force, the formula is we have centripetal force equals mv squared over r. Now take note on this particular formula, guys, very important. Whereas centripetal acceleration is v squared over r. So take note of these two expressions we have here. Since we are looking for centripetal force, and in this question we have our m to be 2 kg, we have our v to be 10 meters per second, and we have our r, the distance, to be 4 meters. So when you plug these values in this expression, we're going to have our mass is 2, alright, times 10 over 4. So this will cancel itself. We cancel this one. We're left with 2. 2 cancel itself. 1 cancel itself. We have 5. So our final result, centripetal force, will be 10 times 5, which will give you what? 50 Newton. So the correct option this question is what? Option D, 50 Newton. Is as simple as this. This is basically how you can deal with problems involving motion in circle for physics. We practice with 7 repeated questions in this video. Hope there's something interesting from the video. Let's click the video, guys. If you're new to our channel, once more, ensure that you are subscribed to this channel for more of our videos. Also like, share, and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I've talked about in this video, feel free to leave a question in the comment section below, and I'll ensure to give you a response. Also ensure that you are part of our channel membership by clicking the join button. In our channel membership, we share special information to those that are part of it that helps them at great length to excel in their external exams easily. Alright, so ensure you're part of us, and we meet you at that side. You'll be glad you did. Thanks for watching. Click on the screen above, and I see you in the next video.